All right, guys, for our first video that we are going to do for our online school is 21-2 Exponential Growth and Decay. This is actually a pretty easy subject because all it is an equation that we plug stuff into, use our calculator, and get an answer. So let's start off with just going over what the equation looks like. So the equation is A is your initial amount, 1 plus R is your rate. We use the plus if it's a growth, and we use the minus if it's a decay. The T up here is in time. All right, so let's look at it one more time. So the A is the initial amount, it's what you started with. Your T is in time. Your R is your growth or decay rate. So we want to make sure that we write that as a decimal. Most of the time in the example, it's going to give you a percentage, but then you're going to move your decimal over two places and get a decimal. We do have a growth or decay factor, and all that is if you look right here, it's 1 plus or minus R. It's just whatever is in your parentheses. That's the growth factor or decay factor. Okay, so let's just start some because, again, like I said, it's not that big of a deal. It says the population of a town is modeled by P equals 6,191 in parentheses 1.04 to the T, where T is the number of years since 2000. What was the population in 2000? So basically it's asking what is the initial amount? What did they start with? Okay, so the initial amount here, remember, it's right in front of the parentheses. So 6,191. What was the rate of population growth? Now, in here, we know we're doing growth. We know R is our rate, but we got to kind of first find it. So we'll say 1 plus R has to equal the 1.04. Okay, because that's what is inside the parentheses, and we're trying to find the rate right now. So if we subtract off the 1, we get 0.04. Now, what is that as a percentage? So remember, when we do percentage, we just move the decimal over twice. So 1, 2, so that means our growth rate is 4%. Okay? Now, it does ask you now to use the formula that they've given you to find the population in 2006. So that just means from 2000, this is our initial, from 2000, I want it 6 years later. So in there for the T, I'm going to put a 6. So I'm really in my calculator going to have 6,191, 1.04 raised to the 6th. Okay, pretty easy. Let me grab my calculator so I can kind of show you the buttons. So literally you just put it in just the way you see it. So 6191, 1.04, and then use your caret to raise it to the 6th. And there it is. So this is a population, so I would probably only round to the tenths. So let's see, we got 7,833.6. Okay? All right, let's try again. It says a new car costs $23,000. The value decreases 15% each year. Now they're going to use specific words in order to help you figure out if it's a decay or a growth. So this one says decreases, which is kind of like a negative word, just like decay is. So I am going to use decay instead of growth. So it says write an exponential model. So anytime it says that, I just want you to write the equation. So just like up here, I'm going to have y equals A is our initial amount. It says your initial amount is 23,000. Parentheses. We know it is a decay because it says decreases, so I'm having 1 minus, and it decreases 15%. When you put the rate inside the parentheses, it has to be a decimal, not a percentage. So 15% is equal to 0.15 as a decimal. Raised to the T. Okay, so there's your exponential model. And again, the reason why it's an exponential model is because it's got that exponent of T. Find the value of the car after 3 years. So 3, that's just your time. So we're going to put in, for the T, a 3. So again, we place it directly in our calculator. The way that you see it is the way that you're putting it in your calculator. So 23,000, 1 minus 0.15, caret to the third. Now this is money. So should we round to the tenths this time? No. So remember, when you have money, your cents value has 2 digits. So when you have money, you should be rounded to the hundreds. So you have 14,124.88 cents. So again, make sure when you are dealing with money that you use the correct rounding technique. Estimate when the car will have a value of 9,000. Okay, so for me, it just depends on what you want to do. Like for me, I like to put my equation into the y equals 1 minus 0.15 raised to the x. Then if you go to second table, you can kind of see, I'm in the negatives right now. I don't want to be in the negatives. But if I go to my table, I can cruise around until I get to approximately 9,000. And if you look right here, between year 5 and year 6, that is when it's going to touch the 9,000 mark. Okay, so that's what I like to do. But you can always plug in numbers for t, kind of guess and check. Okay, but this I find a smidge easier because you're just putting your calculator. Your calculator is doing the work for you. So I'm going to say between years 5 and 6. Okay, so between years 5 and 6. All right, so those are 2 examples for the growth and decay. Now we're going to talk about compound interest. His equation is a smidge different, not a huge amount. So let's kind of look. P stands for the principal, and that's the same thing as the initial amount, just like in the above equation. We have our 1. We do just have a plus sign this time. There's not a plus or minus. It's always a plus there. We have R, which again is your rate. Here's something new. Here's an N, and that's the number of times it gets compounded per year. So sometimes they'll say it gets compounded annually, quarterly, semi-annually. It just kind of depends. We're going to do an example of each one, so don't worry if you don't know those words. Again, it is raised to the N, which is the number of times it's compounded, and the T is your time, which again is in years. So let's just try example 3. I'll show you kind of the different words that it might use. So it says you deposit $1,500 into a bank account that pays 6% annual interest. Write an equation to find the balance after 7 years if the interest is compounded. Now they're going to give you those examples. Annually, semi-annually, quarterly. So let's go ahead and set up an equation. I'm going to say A equals. So your initial amount is $1,500. That's what you started with. We've got our 1, we got our plus sign. The rate is 6%, but remember, anytime we put it in the equation, we're not going to say 6%. We're going to say it as a decimal. So you've got to move that decimal over twice, which is 0.06. Now, compounded annually, that means once per year. So annually, once per year. So down here for the N, there's going to be a 1 down there. Once per year. And then we're going to raise it to that 1. And then we have 7 years. 1 times 7. Okay, so again, I'm going to put this right in my calculator. Do I have to put the 1s in my calculator? No. So I've got 1,500, 1 plus 0.06 raised to the 7. Now this is money again, so remember with money, we always make sure that we have both cents. So 2,255.45. Okay, so now let's go again, semi-annually. So everything is going to be the same except for the way it was compounded. Now this one is semi-annually. So how many times do you think that happens per year? Good, twice per year. So again, all the things that change are just the N. The only thing that's changing is your N. You have to be careful when you put this in your calculator. You need to use the parentheses around that 1 plus 0.06 divided by 2, okay? So make sure there's parentheses around there. So 1,500, 1 plus 0.06 divided by 2, raised to the, and I'm just going to put 14, but you can put 2 times 7. So we get, and again, money, 2,268.89. Okay? All right, one more time. Same equation, but this time we are compounding quarterly. So what do you think quarterly is per year? I mean, you guys know what's quarters, like in a dollar. 4 times, right? 4 times per year. Let me scoot my paper over because you can't see it. So again, our N is just changing to 4 times because we're doing it quarterly. I'm going to put this in my calculator, but make sure that you put parentheses around this or your calculator is not going to like it. So 1,500, 1 plus 0.06 divided by 4, raised to, then again, I'm just going to put 28 up there because I can do it in my head, I might as well. And we get 2,275.83. Okay? If your goal is to have 2,500 after 7 years, how much would you have to initially deposit in the account from Part C to meet your goal? Okay, so it wants you to do it quarterly, but it says that you want to have 2,500 in your account. So that's kind of like your ending, like what you want to end with. So if you were looking at the equation up here for compound interest, and 2,500 is what you wanted to end with, where do you think that goes in the equation? Yeah, that goes in for A, the total. That's what you want to end with. That's not your initial amount. So I'm going to put the 2,500 right here. I have no idea what the initial amount is. That's what you're trying to figure out. And it says that you want to do Part C to meet your goal. So over here where it's 1 plus 0.06 divided by 4, 4 times 7, it wants you to use this part. So we're going to have 1 plus 0.06 divided by 4, 4 times 7. Now, don't look at this and think you have no idea what you're going to do. Okay, you guys have passed Algebra 1. You should be able to do this type of thing. This whole thing right here can go in your calculator. Leave that X alone. Just leave them right here. I'm going to put this whole thing in my calculator. 1 plus 0.06 divided by 4 raised to the 28th. All right, now this is like 1.517 something, 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 something. You guys have to know, here, let me show you, how to bring this back up in your calculator. So sometimes it's not best for you to continuously round things off, okay? That messes with the total. So what you want to do so that you can get all of these numbers in your calculation is we're going to take that 2,500 and we're going to divide it by this answer right here. But how you do it is you hit the second symbol, second, and then down here on the minus sign it says answer above it. So see what it's doing? It's taking the 2,500 and then it's dividing by the answer from the previous thing right above. Okay, so when we push enter, we didn't round anything off. And that's kind of important. Like once you start rounding stuff off, that's when you start to get further and further away from the real answer. So for D, our answer for X's, our initial deposit would need to be 1,647.75 cents. If you wanted to accrue to 2,500, your initial amount needs to be this 1,647.75. Okay? All right? It's not that bad. You just got to know how to use your calculator. All right, example 4. In 2010, the cost of tuition at the state university was $9,420. During the next 8 years, the tuition was expected to rise 4% each year. Write a model that gives the tuition Y in dollars, T years after 2010. Then we're going to estimate the cost. So first we're going to write the model, which is just the equation. Then we're going to plug in the year. Now, it switches back and forth here. If you guys do not see the word compounded quarterly, compounded monthly, compounded annually, then you're not doing compound interest. You're just going right up to the beginning and doing growth or decay. Do you think this guy is a growth or decay function when it says rise 4% each year? Yep, it is growth. So we have Y equals, our initial amount was 9,420. We're doing growth, so we have 1 plus. Our percentage is 4%, but remember we got to put it in as a decimal, and it's rise to the t years. Okay, so that is our model, which again is just our equation. We want to estimate it for 2017. So if it starts at 2010 and goes to 2017, how many years have gone by? Well, it's kind of weird because it asks for 2017 here, but it says during the next 8 years. I say let's go ahead and still put a 7 in, because from 2010 to 2017, that's only 7 years, so I don't really know what they're talking about up there, but let's just go with it. Let's just go with 7. So again, when we put it in our calculator, it's easy. Nothing crazy is happening. But remember, we are still dealing with tuition, which is money. So we're going to make sure we use both cents. So it's 8%, or it's 8 cents. Don't round that off, okay? All right, one more, guys. The amount Y in grams of a sample of iodine 131 after T days is given by this function. What is the initial amount of the substance? So it's giving you the equation. Now you're just picking stuff from it. So the initial amount is always right in front of the parentheses. So we know our initial amount is 50. B, what is the daily percent decrease? Okay, so what it wants to know is what is the percentage? What is the rate? So because this says decrease, you're going to do 1 minus R is equal to whatever is in the parentheses, which is 0.92. Okay, and then we're going to solve this guy for R so that you can actually see the rate. So I'm going to subtract 1 from both sides. So I'll do 0.92 minus 1, negative 0.08. And we know I'm going to divide by negative, so I'll get 0.08, which is equal to 8%. Okay, so again, anytime it's asking you to find the percentage, you have to do either 1 minus R or 1 plus R, because you got to figure out what's in that parenthesis. How many grams of the sample are left after 3 days? So what we're going to do is we're going to plug in the 3 for the time. So you have Y equals 50, 0.92 raised to the 3 days. Now this is just iodine 131. It's not money. So what I'm going to do is I'm just going to round it to the tenths. So I get 38.9. All right, you guys, like if you turn in the next page of your packet, here, let me get my packet, and I'm turning to the next page. This is what your homework is right here. So 21-2, it goes to 17. You're doing the same exact thing. So if you need to watch the video again, you watch the video again. All right, good luck. Again, we'll have office hours to help you. Just let me know.